Now, if you wanted it to pass the vertical line test after you flipped it over the line y equals x, in other words, if you wanted your inverse to be a function, can you see that your original graph would have to pass a horizontal line test? Because if your original graph passed a horizontal line test, then your new graph would pass the vertical line test. So what we're going to do with this graph, and they've given us x minus 1 squared plus 3, so that's a parabola, moved 1 to the right and then 3 up, and you can see the vertex is at 1, 3. It says, can you come up with 2 different ways to restrict the domain? In other words, we're going to only say part of the x values so that our original graph passes that horizontal line test. I'll do it with color coding with a highlighter here. So can you see if I started from my vertex there, but only included the right side, that would pass the vertical line test and the horizontal line test? Or I could start at my vertex and do the left side. The green part passes the horizontal line test when you're just thinking about the green part. The yellow part passes the horizontal line test if you're just thinking about the yellow part. But when you have all the red together, it doesn't. So what are the 2 ways that we can restrict the domain? One, we can say x could be bigger than or equal to 1, because that's the key point here is this one, 1, 3. And generally, if we restrict the domain as bigger than or equal to 1, when we restrict it the other way, we don't include the equal sign. But it doesn't matter where that is. It's just so that you don't use 1 twice in both of them. Now, to find the equation of the inverse each time, it's going to start off, I'm just going to erase some of this line. I'm going to start off finding the equation the same way I always have. Switch the x and the y. Use my skills. Use my skills to solve for y, so I'm going to subtract 3 on both sides. Square root both sides. Remember the plus or minus. And then finally, add 1, so I get y by itself. Now we have to decide which one goes with which part. And maybe you even want to write this as plus or minus x minus 3 plus 1 on that side. Doesn't matter, but if you have it the second way, then you can see that that plus 1 at the end would be a shift up or down. Right? And the plus 1 would make it shift up. These plus or minus out front, the minus would be a reflection over the x-axis, because that would be outside of our function, of our square root function. Graphically, you may want to draw the line y equals x on here and start by labeling 3, 1. Can you see that the parabola is going to look like this when it's flipped over? Which part goes with which part? Can you see from the graph? Whoops, it's not yellow. That'll be our yellow part. and this will be our green part. So that means our yellow part is when x is bigger than or equal to 1. That corresponds to x minus 3 plus 1. And the green part corresponds to the negative 1. So again, I'll highlight. Oh, highlighters are not being nice to me. If it's hard to see it as far as the flip part goes, again, you can turn your page sideways. That's often or turn it diagonal so you can really see the flip. Then you'll see that the yellow part flips to the yellow part and the green part flips to the green part. You could also take a point, another point on our original graph, say this one at 2, 4, and say, where does 2, 4 go? Because it's on my yellow graph, it'll go to 4, 2, and you can see that that's on the top section to see which part goes with which part. So what we were able to do here is we were able to split the domain. We were able to find the equation of the inverse for each domain, and they're different. One is the positive part, one is the negative part. And as far as illustrating a graph, you can color code it like this on your test or exam. When I ask a question like this, you can color code one part and say it goes with the color coded part on the other one. And you can do 10 and 12.